This is the video for section 7.2. It is a little bit longer than most of them, but it's basically one example, and I didn't want to split it up. So the section 7.2 title is Applications of the Normal Distribution, and we're going to look through an example and figure out how to find and interpret the area under a curve. And we're also going to find the value of a particular area. So if we know we want the top 10%, what score or what value would that be? Or the 15th percentile. So we'll look at that as well. As far as our ESEL lens, this, like I said, is really just an example that's putting in the application and how we use that normal distribution. But I didn't want you all to think that I had forgotten about the lens or to include it in the video. All right, the first thing I want us to think about is just this idea of z-scores. If you do have a question in the homework asking you to find a z-score, it's because the z-score, remember, we stopped our last video with the question, what if we're not exactly 1, 2, or 3 standard deviations away? And our z-score is specifically tells us how many standard deviations from the mean we are. So z-score is the number of standard deviations, I'm going to abbreviate SD, above if it's positive, or below if the z-score is negative, the mean. So for our empirical rule, we already know the areas or the percentages under that curve. If we're exactly 1, 2, or 3 standard deviations away, before we had technology, we would need the z-score so we could look up in a table to find the area based on being, if we were, 1.17 standard deviations above the mean. So if I knew my z-score, there's a table I could look up the value in and I could find the area. We don't have to do that, but just kind of a refresher, that's what's going on in the background. All right, so this is the situation we're going to be looking at for the example of this video, and that is that we're going to suppose that the lifetime of AA batteries are approximately normally distributed with a mean of 21.7 hours. So I'm going to go ahead and write that down. 21.7, and a standard deviation of 1.2 hours. So that's going to be our identifying information. And remember, since it says approximately normal, then I can use the normal distribution with my mean and my standard deviation. All right, so if we want to figure out the possible values of X, where X is the length of time that the AA battery will last in hours, of course, you could end up with a dud, and it could be 0. Of course, we can't have a negative time. But really, I mean, I know that a battery won't last literally infinity hours, but we don't really have a known stopping point. So I'm actually going to go ahead and just put infinity. Now, with a mean of 21.7 hours, I think it's pretty safe to say, that it's very reasonable to look at it. What would be, remember, 99.7% of our data is within 3 standard deviations. So if we go 3 standard deviations up, or even 4, that would be adding 4.8, which would be 26 point something. So let's just say 27. We'll kind of round estimate. That, that's also a reasonable range. And really 0 is too much. It would probably be more like, although I guess there are those moments when you really do have a dud, that like you buy a new battery and it doesn't work at all. So we can leave that. So our possible values, though, the main idea here is that it's continuous. Oops. That's the main idea. All right, and if we want to draw a graph of our probability distribution, well, we knew it was normally approximately normal, so a normal distribution. So I'm going to do my best. Do this better with pencil and paper. But I think I did pretty good. Now, I don't have to do the whole empirical rule, but I do want to mark my mean and label it. And I like to go ahead and draw a line out kind of in this upper region, about 1 standard deviation away, just, wherever, somewhere up here, and I label it as well, standard deviation 1.2. And that way I have those as reference on my graph every time I need to use it. And I will use it every time I find a probability. All right, so now we're actually wanting to find a proportion, or what's the probability. All of these things mean the same thing. What percent of batteries, what proportion of batteries, what's the probability that a battery will last. All of those questions end up doing the same process for finding the answer. So we want to know what proportion of AA batteries will last more than 24 hours. Well, I'm going to go ahead and just put my curve that I just drew back on there. And 24, well, so I've got 21.7 here. 24 just needs to be somewhere along this side of the graph. I'm not worried about if it's really where the 24 would be based on this being 1.2 away. Does that make sense? So I just want to draw it enough to know that wherever I draw my line, I'm going to say that's 24, and we're just going to go with it. And then I need to shade. So last more than 24 hours. Well, 24, and then I'm going to be shading this way. That's important because we need to make sure that we have the right inequality symbol when we put this into StatCrunch. All right, so I didn't record my screen on my computer for this part, but when you go into StatCrunch, now it's not going to give you the option to open in StatCrunch because the data, it's not data, it's just statistics. But when you click on question help, StatCrunch should be an option under there. So for me, when I'm looking at one of the homework assignments, it says, help me solve this, view an example, StatCrunch. And then Tech Help. So the Tech Help is under there as well. So if we open up StatCrunch, you don't have to put anything into the data or the sheet itself. You actually just go straight to, Stat, and the very first option, Calculators, and then Normal. And when you select that, you'll have two options, Standard and Between. So Standard just means either to the left or to the right, depending on which symbol you choose down at the bottom. And if you're looking at it like I am, you've got a mean of 0, standard deviation of 1, and probability that x is less than or equal to 0 equals 0.5. So we can go in and change the mean and standard deviation. So for our batteries, our mean is 21.7, and our standard deviation is 1.2. And we are looking for greater than, so I need to change that symbol. Right now it's less than or equal. I want greater than or equal to 24. Now when I hit compute, it'll give me my answer. And so I'm getting that this area is, I'm going to just always do 3 decimal places for probability and 1 decimal place for time or hours. So 0.028. So it's 0.276. It keeps going, but rounds to 0.028. So not very many will last more than 24 hours. All right, and for this next one, we want to know what proportion of batteries will last 21 hours or less. Well, I like to continue and keep this same curve. Move it over here a little bit. But now I want 21 hours or less. Now, even though 21 would likely be closer to the mean, maybe here, I'm not drawing for accuracy. I'm drawing so that I know which way to shade. So I'm still going to mark it about right here. That is not a reasonable place to mark it as far as the scale of the axis, but that's not the point. The point is that we know which way to shade, and we know to the left or to the right of the mean as far as where our number should be. Now, this should be, just looking at it, I'm thinking it should be somewhere close to 50%, but less than 50%. But that's what I'm looking for. Less than 21 will be that area right there. And so again, when I go into StatCrunch, I'm going to keep my mean and standard deviation the same. I do need to change my symbol now, because now I'm looking for the probability that x is less than or equal to 21. And so I'm going to change my symbol to less than or equal, and change my 24 to 21. And when I hit compute, I get the probability of 2798. So that 8 will make the 79 become an 80. So 280. There we go. All right, so on this next one, we want to know what proportion of AA batteries will last, that should say, between 19 and 21 hours. So, of course, we want our normal curve. We'll use it every time. And we'll mark 19 and 21. So again, 21 doesn't have to be, right up next to the mean, even though it probably is. 19 might be right in there somewhere. And of course, we just want to mark what are we looking for? Well, we're looking for the shaded region between. So I need to go to my normal calculator, and instead of being on standard, I want to click at the top. I want to switch it to between. And what you'll see, we still have the same setup as far as mean and standard deviation, but now we have probability, and then there's a box to fill in, less than or equal to x, less than or equal to, and then we put our upper value. Well, those two values, of course, are the two numbers that we want to find in between of. So 19 and 21. All right, so I'm going to change the -1 to 19, and I'm going to change the +1 to 21. Click compute, and we've got 0. See, again, 3 decimal places, so 268. So there's our probability. All right, so this one is a little bit different. So the Lotso Energy battery company, yes, I made that up, don't judge me, is considering a money-back guarantee for their AA batteries, but only want to risk having to refund 2% of their sales. So like if your battery doesn't last, and then they're going to find some time to say, if your battery doesn't last at least this long, then we'll give you your money back. So what battery life in hours, and again, we're going to round just to 1 decimal place, should they advertise for this money back guarantee? So first of all, we kind of need to figure out what does this even mean, right? What does it mean if they're going to have to refund 2% of their of their sales? Where is that on our graph? Well, let's see if we can put our graph back up here. And actually, you know what? I'm going to not do that. I'm going to delete that. I'm just going to get us a new page because there's not really a lot of room here. So let's remember they'd only want to risk refund of 2% of their sales. All right, so if they're going to refund no more than 2% of their sales, let's go ahead and paste our graph. I still want to use that. So what does that look like? So does that mean that they want some value up here where 2% of their sales are this shaded region? Is that what we want to do? Well, this is what we're looking for is we're going to call it X. We're looking for X. So we're looking for the cutoff. We're going to refund if your battery doesn't last this long. Well, that's going to be 98% of their batteries aren't going to last that long. So we do not want that 2%. That is not the 2% we want. So I'm just going to move that off. And we're going to look at it again. So if I want to refund 2% and I've got down here, and this is 2%, then what value is this? Well, now that's a lot better. That means that if my battery doesn't last this long, whatever this value is, they'll refund my money. But if my battery lasts 20 hours, I'm probably not going to get a refund, right? Because 20 is probably closer up into like this area. If my battery lasts more than on average, I'm definitely not going to get my money back, right? So we want to know what value this is, though. So in order to do that, we're going to use the exact same normal calculator. We're just going to fill in the different blank. So instead of saying, we basically, what do we want? We want to know that the probability that X, I'm going to use a capital X, right? Because that's the capital letter that they're using in the calculator or in the StatCrunch, is less than this little x is equal to my area. Well, remember, area has to be between 0 and 1. So if a percentage, I need to change it to a decimal. And I can fill in this number. So yes, you'll have whatever we just had typed in there. So you need to go back to standard. So if you go back to the standard one, not between, but standard, and you'll want X is less than or equal. And then it doesn't matter what's in that next box. But in the equals, where we were getting our answer, we're going to type in 0.02. And when we hit compute, we'll get our X. It will fill in for us. So in this case, X is going to equal 19.2 hours. All right, and then we've got one more example for this one. And we want to know how long would the top 1% of AA batteries last. So this is going to be like our best of brand. Maybe we're comparing lots of different brands of batteries, and we want to know what that top 1% would be. Well, let's go ahead and draw our curve again. Get used to that. And then we're going to mark. So if I want the top 1%, well, remember, this is below average. And this is above average. This is still an x-axis on the bottom here, and it still goes in regular order that we're used to doing in any math class when we graph. Smaller numbers to larger numbers. So if we want the top 1%, then that really means to the far right. So we want somewhere over here is a value that's going to give us 1% of our area to the right of it. And so again, when we put this in StatCrunch, we're going to have this probability X. Now we want greater than or equal to what value, and it's going to be, you know, you can just, there might be a number in there, but that's what we're going to try and fill out. And then we've got this, and we want to say 0.01. And so I'm going to change the 0.02 to 0.01 and click. Oh, and I need to change my sign. I almost did. Well, I'm not going to do it. I'm going to click compute, and I'm going to get 18.9. Now, does 18.9 sound like a superlative battery when average is 21.7? I have the hiccups, I'm sorry. So it's okay if we make a mistake. We just need to recognize that it's a mistake. And we can if we put just a little bit of logic in there. So I didn't change this sign right here. And I went ahead and hit calculate. And I got 18.9. Well, no, that is not the top 10%, or even top 1%, excuse me. That's the bottom 1%. So I've got to make sure, if you get a number like that, this is why the drawing helps. Because you see where the mean should be. You see that we're over here. We should be higher than that. I don't know how much higher. I just know higher than 21.7. I'm thinking, you know, 22, 23. I don't know yet. That's why I have the calculator. So I'm going to say greater than or equal. And now I've got to go back and put in the 0.01 again and hit compute, because it tried to compute with the 18 that I had in there. Compute, and I'm getting 24.5. So when I did that, I'm getting, excuse me, I put X, I put P, I meant X. So this is a big X, remember this is a capital X. So the little x, this little x here, is 24.5. So if our AA battery lasts 24 and a half hours, then that's a really great battery. That is the cream of the crop.